So in this video, we will take a look at the concept of double integrals, and we will have a look at some examples of computation involving double integrals. We start with the region R in the xy plane, and in that region R, we suppose that there is a function f defined for all x and y in this region R. And then we want to find the integral of this function f over this region R, like this. So double integral, you can use dA, you can also use dx, dy, or even dy dx. Now, these double integrals will be calculated in various ways, depending on the region R itself and also on the function f. So first case scenario is a region R, which is just a rectangle, like here. You can see the region is x varying from A to B, like this, and y from C to D. So in the end, here the region R is just a rectangle. So here is an example. R is the rectangle where x is between 0 and 2 and y is between 1 and 4. And we want to evaluate this integral, the integral of the function 6x squared plus 4xy cubed dA. In this case, it really does not matter. We can start by integrating with respect to x. So for xy cubed. So I will integrate with respect to x from a to b, here 0 to 2. And then the result will be integrated with respect to y from 1 to 4, like this. So we keep 1 to 4, and then we integrate. Okay, we're going to calculate the integral, this integral here. So 6x squared, integrate that with respect to x. That will give us 2x to the power of 3. And then 4xy to the power of 3, integrate that with respect to x, we get 2x squared y to the power of 3 from x equal to 0 to x equal 2. And then once we have this answer, we will integrate the result with respect to y. So the next step will be to substitute x equal 2 in this expression. That will give us 16 plus 8y to the power of 3. And the substitution with 0 will give 0, so that's it. So dy, and then we integrate this with respect to y, so it's 16y plus 2y to the power of 4. Evaluate this at 4 minus its value at 1. So it's going to be 16 times 4 plus 2 times 4 to the power of 4 minus the value when y is equal to 1. So it's 16 times 1 plus 2 times 1 to the power of 4. If you do these calculations, you will then get 558 as the value of the integral. Okay, so the second situation we can have is a region R, which is between two curves, one y equal g1 of x, the lower curve, and an upper curve, y equal g2 of x, and then the values of x go from A to B. So that is the region R this time. In this situation, the way we integrate the function f in the region R is to integrate first with respect to y from here to here, so from G1 to G2, and then the second step is to integrate with respect to x from A to B. So these are the two steps that need to be followed to find the integral in this situation. Okay, in this example, we have a function f of xy, and we want to integrate it in the region R, bounded by the line y equal x, the line y equals 0, and the line x equal 4. So the first thing we need to do here is to actually graph this region R. So we need to know, how does this region R look like? Okay, so x and y axis. The line y equal x is this line here, y equal to x, and then y equals 0 is actually the x-axis, and x equal 4 is a vertical line like this. So this is the region that we are talking about here. So this line is x equal 4, this line is the y equal to 0, and this line is the y equal x. So this is the region R in which we want to integrate. Well, we can do that integration by doing the following. We will integrate with respect to y from y equal to 0 to y equal x. So 4 ex squared minus 5 sine y. First with respect to y, and then with respect to x from, you can see that in this region R, the values of x are going from 0 to 4. So this will be from 0 to 4. So that's basically the way we are going to do that. Now the rest is fairly simple. I think there are no big issues in integrating. So first we will integrate, of course, with respect to y. So first we need to calculate this with respect to y. 4ex squared multiplied by y minus the integral of sine y, which is basically cosine y. So 5 cosine minus cosine y, and then from y equal to 0 to y equal x, and then dx. Okay, so now we substitute. It's going to be 0 to 4. The substitution will give us 4x ex squared plus 5 cosine x, and then when we substitute by 0, when we put y equals 0 in this expression, we will get the 5. So it's going to be minus 5, and then all of this integrated with respect to x. Now this integral is going to be this. Think of this as 2 times 2x ex squared. So it's going to be 2 ex squared when we integrate. Then the integral of cosine will be sine. Okay. And the integral of minus 5 will be minus 5x, and from 0 to 4. We substitute now x equal 4 and x equals 0. We will get the following. So 2e to the power of 16 plus 5 sine 4, okay, minus 20, and then minus, substitute with 0, and it's going to give us 2 here. The other two terms are equal to 0. So in the end, final answer, 2e to the power of 16 plus 5 sine 4 minus 22, and that is the final answer. So a third situation with the region R, this time between two curves. On the left side, x equal h1 of y, and on the right side, x equal h2 of y, and then y from C to D, like this. In this case, well, we first need to integrate with respect to x from this curve to this one, and then we integrate the result with respect to y from C to D. So this time we need to start with an integration with respect to x. So here is an example. The region this time is between the curves x equal y squared, x equal to y squared, which is the parabola with axis the x like this. So this is the curve x equal y squared, and then x equal 2 minus y is a straight line through the point 2 and 2 here. So it's going to be like this. So the region R is this region bounded by these two curves, x equal to y squared on the left side, and this line which is x equal to 2 minus y. So what we'll do here is we will integrate in this direction with respect to x first, and then we will integrate with respect to y from this value to this value. And we need to find now those values of y. So we need to find the intersection of the two curves. So we need to solve the equation y squared equal to 2 minus y, which is basically a quadratic equation, which has two solutions, y equal to 1 and y equal to minus 2. So these are the boundaries for the variable y. So now we can show our integral of f. We're not given f, by the way. We just want to write the integral as an iterated integral. That means, so integrating over r will be an integration of the function f with respect to x from x equal y squared to x equal 2 minus y, and then the answer to that will integrate it with respect to y from minus 2 to 1, from minus 2 to 1. That's it. Okay, here we need to integrate this function in the region R bounded by the graph y equal square root of x equal to 0, and y equal to 3. So if we graph this region R, it's always important to graph. So we have y equal square root of x, which is this curve, y equal to square root of x equal to 0 is, okay, so this is y equal square root of x equals 0 is the y-axis, and then y equal 3 is the line which goes through this point, y equal to 3. So the region R is this region here, and we want to integrate, okay, so I want to integrate 2x y squared plus 2y cosine x dA over this region R, like this. Okay, I think we can integrate first with respect to x if we want, or with respect to y. It doesn't really matter that much here. Both will work, but if I decide to integrate first with respect to x, then it will be from x equal to 0 to this curve, which is, if I square both sides, it becomes x equal y squared. So this integral, I can actually write it as the integral from 0 to y squared, 2x y squared plus 2y cosine x, so dx, and then the answer will be integrated with respect to y from 0 to 3, 0 to 3, like this. Perfectly okay to do it this way. So I'm integrating with respect to x from left to right, and then with respect to y from down to up, so from 0 to 3. Now the rest is fairly easy. To integrating this with respect to x becomes x squared y squared, and then integrating this with respect to x, 2y is a constant, the integral of cosine will become sine, so it's this from x equal to 0 to x equal y squared dx. Yeah, so now I substitute, so it will become, if we substitute, we have an x squared, yeah, we have an x squared here, and then by substituting, it becomes y to the power of 4 multiplied by y squared, so final answer here, y to the power of 6 plus 2y sine y squared. And then the substitution with 0 will give us 0. So it's all of this dy. So now I need to integrate with respect to y. Fairly easy. So it's going to be y to the power of 7 over 7 plus, actually it's a minus, yeah, it's minus cosine y squared from 0 to 3. So we substitute now, and we get 3 to the power of 7 over 7 minus cosine 9 minus the substitution with 0 will give us minus cosine 0, which is minus 1. So in the end, 3, okay, I'll give you the answer in decimal form. Very close to 314 is basically the final answer here. Okay, final example, a situation where we need to change the order of integration to actually calculate the integral. If we try to integrate this function, ex squared dx with respect to x, well, we don't know what this is. It's impossible to calculate it. And therefore, we need to change the order of integration. We need to switch the order of integration. We need to start with y. But to do that, first we need to determine the region R. What is the region R in this example? Okay, so we can determine it by looking at the boundaries here. You can see that x goes from x equal y, which is the line, x equal to y, to x equal 1, which is the vertical line, yeah, x equal to 1, and then y, we can see that y is between 0 and 1. So in fact the region R is basically this triangle, yeah, 0, 1 here, the y here is 1, so it's actually this region. This is what R is. And to integrate in this region R now, so 0 to 1, y to 1, ex squared dx dy, I will start now by integrating with respect to y, okay? So we start with y from y equals 0 to y equal x, which is this line here. And then the result, I will integrate it with respect to x from 0 to 1. So I'm changing the order of integration, and it becomes this integral. Now it's okay, because this integral is just ex squared multiplied by y from y equal to 0 to y equal x, and then dx after that. Okay, so that will give us, okay, so that's going to give us the integral from 0 to 1 of x squared when you substitute here, and then y equals 0 substitute will give you 0, so this is dx. Now this integral is actually okay, because I can introduce 2 here and a half. Now the derivative of x squared is 2x, so this is just half of ex squared when x goes from 0 to 1. So therefore, so it's going to be half, and then we substitute, we get e, and we substitute, we get 1. So it's half of e minus 1, which is the final answer.